Welcome back to the deep dive. You know, there's that universal feeling, right? That frustration when you're trying to talk to an advanced AI.
Oh, yeah.
You've spent time crafting what seems like a perfect instruction, a really detailed prompt, and then the output just completely misses the mark.
Right. It's either way too broad or kind of nonsensical, or maybe just flat out ignores something crucial you mentioned like 2 messages ago.
Exactly. It's like talking to a wall sometimes.
It really is. It's been the biggest friction point, hasn't it? For ages, the thinking was, okay, we just need better prompts, better magic words.
You had to find that perfect phrase.
Yeah, everyone was chasing that.
Yeah.
But then recently we saw this, well, almost a backlash. Headlines popping up saying, prompt engineering is dead.
Ah, yes, I saw those. Bit dramatic.
Totally. Suggesting we need to forget prompts and focus on this bigger thing called context engineering.
Okay, let's jump right into that, because the material we're looking at today, especially this really thorough preprint paper from Shanghai Jiaotong University's GAIR lab, what's it called? The Context of Context Engineering.
That's the one, a really comprehensive overview.
Right. It basically suggests those headlines, while catchy, kind of misunderstand the whole picture. So our mission today is really to dig into that relationship. Prompt versus context engineering.
Exactly. And job number 1 has to be setting the record straight. This whole prompt engineering is dead idea, paper sort of implies it's like intellectual clickbait.
Correct nonsense was the term, I think.
Yeah, something like that. Title bait. Prompt engineering isn't dead at all. It's just being put in its proper place. It is and always will be a vital part of the much bigger picture, which is context engineering. Think of it as the starting point.
Okay. That changes the perspective completely. So they're nested. The prompt kicks things off, but it's part of this larger context management. But to really get why context engineering is the main umbrella, we need to understand the fundamental communication gap, right? Between us and the machines. The paper calls it the entropy gap.
Yeah, the entropy gap. The brilliant way to frame it, borrowing from physics, actually.
Yeah.
Think about how we humans talk. It's naturally high entropy.
High entropy, meaning messy, ambiguous.
Exactly. Messy, fuzzy, full of assumptions, implied meanings. We rely constantly on shared understanding. And crucially, we're totally comfortable working with incomplete information.
We are. We finish each other's sentences. We get the subtext. If I lean over to a colleague and just say, hey, can you take care of that report?
Right. The human gets it instantly.
Yeah.
They use years of context, the project, the deadline, your tone of voice, what you talked about yesterday to figure it out.
They know which report. They probably know how urgently. Is it an in-an-hour thing or an end-of-day thing?
That's high entropy in action, rich with human guesswork, basically.
Yeah.
Now, imagine giving that exact same command, go take care of that report, to an LLM cold with no prior conversation.
Yeah, it would have no clue.
Because machine communication needs the total opposite. It demands low entropy, it needs precision, zero ambiguity, structured input, complete details, everything spelled out.
The machine can't guess, or if it tries, it costs a lot computationally, right?
An enormous amount. That effort the machine spends just trying to resolve our human fuzziness, that's the core conflict. That's the entropy gap.
So this gap, this clash between our messy human style and the machine's need for perfect order, that's why we feel like the AI isn't listening sometimes.
That's a huge part of it. If the AI has to burn precious processing power, its attention layers just figuring out what you meant, it often fails to generate the right output. Or worse, it just makes something up, hallucinates.
So that wasted effort, that ambiguity, it translates directly into using more tokens, slower responses, higher costs, and just more errors.
Precisely. The AI isn't being stubborn. It's literally drowning in the complexity, the high entropy of our natural language.
Okay, so if that gap is the fundamental problem, then the whole point of all this engineering effort, the paper calls it the entropy reduction war, is to build a bridge across it.
You got it. And that bridge, the system designed to fight that war and reduce that entropy, that's context engineering.
All right, let's get into the mechanics then. If context engineering is this bridge, taking our high entropy human thoughts and making them low entropy for the machine, how does it actually do that translation?
Think of it as a systematic converter. Or the paper uses a nice metaphor.
Yeah.
Scaffolding, like temporary support. It takes the raw, messy flow of human input, the fuzzy ideas, the half-formed requests, and it systematically processes it, structures it, transforms it into a format the machine can actually work with efficiently.
Ah, this is where that great analogy comes in, the one about the steak and the infant. It sounds simple, but it really clicks.
It's very effective because it highlights this idea of predigestion. So humans, we're the adults in this analogy. We can handle a big, complex steak directly, chew it, digest it, break down all the fibers. That's like our ability to process raw, high-entropy information.
We have the cognitive gear for it.
Right. But the AI, especially the large language model at the initial processing stage, it's like the infant. It can't handle that whole steak.
Nope. Needs baby food.
Exactly. It needs that steak meticulously chopped up, ground down, maybe even pureed into a smooth paste. And that whole process, the chopping, grinding, pureeing, that's context engineering.
So it simplifies the complexity.
It simplifies the complexity, reduces the entropy, without changing the core substance. This is key. It's still beef. The core meaning, the user's intent, stays the same. But it's presented in a way the machine doesn't have to struggle with.
So if it's done right, the model doesn't waste resources figuring out which report I meant. It already knows because the context was engineered properly.
Precisely. It's essentially the AI's pre-digestive system for information. It manages that whole entropy reduction pipeline, cleaning and structuring the input before the main model even starts the heavy lifting of generating a response.
Which means faster responses, better accuracy, lower cost, because the AI's power goes into the output, not just deciphering the messy input.
You nailed it. It's about allocating resources efficiently. And this whole system, this management of complexity, it hasn't always looked like this. It's evolved quite dramatically.
Right. The paper lays out a history. 4 distinct phases or eras of context engineering.
Yeah, the SJTU paper does a great job mapping this out, both historically and looking forward. And they pinpoint a really critical moment, a watershed moment.
The iPhone moment for AI, they called it. The release of GPT-3 back in 2020. Why was that specific model so pivotal?
Because before GPT-3, honestly, using natural language to give complex commands to machines was unreliable. It didn't really work consistently.
You needed code or very specific interfaces.
Exactly. GPT-3 changed the game. Suddenly, natural language became a viable, often even a better, way to interact with sophisticated AI systems. That was the fundamental shift, the line between Era 1.0 and Era 2.0.
Okay, let's walk through these eras. Era 1.0, context as translation. This is pre-GPT-3.
Right. Think traditional computer science. The dominant way to interact was through GUI's graphical user interfaces. The human thought was still fuzzy, high entropy, but the system itself was rigid. It couldn't handle ambiguous speech.
So who was doing the entropy reduction back then? How did my fuzzy thought get turned into something the machine understood?
The humans did it. The software engineers, the UI UX designers, they were the translators. Their job was to take potential human intentions and map them onto very specific, standardized, low-entropy machine actions.
It's like deleting a file.
Perfect example. If you want to delete your Q3 report file, you don't type, "I wish to discard this document forthwith."
Yeah.
You perform a very clear low-entropy action. You click the icon, you drag it to the trash can symbol, maybe you click OK on a confirmation box.
The fuzzy intent to get rid of this gets translated into a standard graphical operation. The HMI, the human-machine interface, did the work.
Exactly. The complexity was managed, abstracted away by the interface designer. It took enormous human effort up front to design those systems, ensuring every likely human goal had a clear, unambiguous machine equivalent.
Which leads us out of the GUI era and into Era 2.0. Context as instruction. This feels like where we are right now, mostly. Conversational AI, natural language as the main interface.
We're definitely in 2.0, maybe transitioning towards 3.0. In Era 2.0, the focus shifts dramatically. Now, we use rich, detailed context delivered through natural language dialogue to directly guide the AI's intent.
And the big technical battleground for this era is the context window wars.
Absolutely. That's the physical manifestation of this entropy reduction effort. All these companies fighting to have the biggest context window, the most tokens.
We hear these huge numbers. Gemini 2.5 Pro is supporting up to 2 million tokens, maybe 1 million available for regular users. That's like having a massive amount of RAM just for the conversation history.
It is. And here's the critical insight for understanding Era 2.0.
Right.
That huge context window acts like a giant entropy buffer. The longer the window, the more conversational history the AI can remember within that single session.
Why is that so important? How does remembering more help?
Because it allows the AI to eventually figure things out, to hit the target, even if your initial prompts are kind of sloppy.
So a long window forgives bad prompting, in a way.
In a way, yes, because the ongoing back and forth dialogue itself becomes the mechanism for reducing entropy. Let's say you start really vague, help me write a marketing brief, super high entropy.
But could mean anything.
But then over the next, say, 30 terms of conversation, you clarify the target audience, you define the product features, you fit the tone, you list the constraints, the budget. By the end of that exchange, even though the initial prompt was weak, the total accumulated context in that long window is incredibly detailed and low entropy.
Ah, I see. The conversation itself builds the specific instructions piece by piece.
Exactly. In this phase, the context becomes the instruction. The sheer volume of dialogue compensates for the initial ambiguity.
So a really practical tip for people using these tools now in Era 2.0 is patience. Keep the conversation going in one window.
Pretty much. Especially for non-trivial tasks. Don't jump between windows too much. If your first attempt isn't great, keep clarifying, keep adding details within that same session. The length of the conversation itself engineers the context.
The AI has enough working memory, enough RAM to hold all those pieces until the picture becomes clear.
Right. But that's 2.0 instruction through dialogue.
Okay.
The next step, Era 3.0, context is seen. This is the near future, and it's a huge leap. This is where the AI starts to understand subtext, emotion, implied meaning.
Okay, that sounds hard. We're asking the machine to go beyond just the words on the page, the syntax and the semantics, and get into human interpretation.
That's exactly what we're asking.
Yeah.
In 3.0, the AI has to figure out the meaning behind the words based on the surrounding situation, the scene. Take the exact same phrase. I need this done right now. If you type that, and maybe your smartwatch data shows your heart rate is sky high, your GPS says you're at the hospital, the AI needs to interpret that as real urgency, possibly crisis.
Right. But if I type the exact same words, I need this done right now, and my location is, say, a comedy club, and maybe my voice analysis shows I'm laughing.
Then it's sarcasm, right? Or playful exaggeration. The words are identical, but the scene, the context, changes the meaning entirely.
So the AI needs to understand the situation to get the true intent. How does it get that situational awareness?
Through multimodal data. And specifically what the paper calls passive distributed information gathering. This is the big infrastructure shift.
Ambient data collection.
Yes. Data flowing in constantly from all our connected devices. Think AI glasses, seeing the visual scene around you, who we're talking to. AI watches tracking your heart rate, stress levels, your physiological state, your phone tracking location, maybe your recent purchases, your calendar appointments.
Wow, all that background data gets pulled together
to establish the user's current scene or mood. That provides the non-linguistic context needed to resolve the ambiguity inherent in just plain text.
So the AI isn't just reading my message, it's reading the room, reading my biometrics, reading my schedule.
Pretty much. It starts to build a level of contextual understanding that's almost like a close friend or family member who knows your situation without you having to explain every little detail.
That's a profound shift, and that leads us towards the really long-term vision. Era 4.0, context as world.
Right. This is where the cognitive gap between human and machine essentially disappears. The AI doesn't just understand the current scene. It achieves a level of cognition where it might even surpass our own understanding of our needs.
Okay, surpassing human understanding. That sounds like sci-fi. Let's ground that a bit. What does that mean technically? Is this just AGI?
It's related to AGI, specifically AGI's mastery of context. The key capability here is what the paper calls active perception and insight. The AI moves beyond reacting to the current scene and starts proactively identifying needs you haven't even articulated, maybe haven't even consciously recognized yourself.
So it's not just understanding my stress, it's anticipating it. Like if I've had a rough week, showing high stress signals, and I start looking up flights for the weekend.
A 4.0 AI might not just help you book the flight. It might proactively analyze your past patterns, your stated preferences for relaxation, and suggest, hey, based on your recent stress levels and past behavior, maybe booking a massage when you land or visiting that quiet park you liked last time would be beneficial. It's anticipating your unspoken contextual needs.
It's predicting my context before I even fully form the request.
That's the essence of 4.0. The entropy war is effectively won because the AI can anticipate and structure the context almost perfectly, minimizing the need for us to provide fuzzy, high-entropy input in the first place.
Okay, that framework, the 4 eras, gives us a great map. But let's zoom back into where we are now, that 2.0, 3.0 transition. To actually get better at this today, we need to understand the nuts and bolts. Principle 1. How does the AI acquire and manage all this context? Let's start with acquisition.
Right. How does the info get in? Well, there are 2 main channels evolving. First is active input. That's what we do consciously.
Typing prompts, talking to it, uploading documents.
Exactly. Text, voice, images, videos, PDFs. And the key here for better context engineering is pushing towards richer, multimodal, active inputs. Instead of just describing a scene in text, upload a picture or a short video. It reduces ambiguity, lowers the entropy right away.
Give it more direct data, less fuzzy description.
Precisely. But the real game changer for context acquisition, looking towards Era 3.0 and beyond, is passive distributed collection, that ambient data stream we mentioned.
The smart glasses, watches, phones.
Yeah. Data collected quietly in the background. The visual scene from glasses, physiological signals from watches, location and app usage from phones. This constant ambient stream provides that rich, underlying contextual fabric that makes the sophisticated scene understanding possible. It just seeps in.
Okay, so the data comes in actively or passively. Then the AI needs to store it and use it. This brings us to its memory systems. Let's talk about short-term memory first, the AI's RAM, basically, corresponding to the current chat session.
Exactly. Short-term memory, often tied to that context window length we discussed, is crucial for conversation flow. It's what lets the AI remember what you said 3 turns ago and follow multi-step instructions within a single session. Systems like GPT are good at this. They maintain coherence pretty well over moderate lengths.
But it's not perfect, right? We've all seen it forget things, the fading effect the sources mentioned. What happens in really long conversations, like 50 or 100 messages back and forth?
Yeah, the fading effect is real. It's essentially a prioritization issue within that limited RAM. The AI tends to focus its attention resources on the most recent inputs, things that seem immediately relevant or urgent.
So an instruction I gave way back at the beginning, like always format code snippets using Markdown.
Might get pushed aside. It's not necessarily deleted from memory, but its priority drops. By turn 50, when you're deep in debugging some complex logic, the AI might forget that initial formatting rule because the immediate debugging commands seem more important. Its attention has shifted.
We see that constantly in coding help. You set up rules, then after a long back and forth, it starts ignoring them.
Exactly. And besides the accuracy issue, these super long rambling conversations also become computationally expensive. They slow things down, cost more tokens. So we need strategies to manage this short-term memory effectively.
Which leads to a really important technique for advanced users, context distillation. The paper calls it Zheng Liu. Is that just summarizing?
It's more than just summarizing. If you ask for a summary, you often just get a list of topics discussed. Distillation is about instructing the AI to actively consolidate the core intent, the operating rules, and the key conclusions reached so far in the conversation.
How's that different? Give me an example.
Okay, instead of saying, summarize our conversation, you'd say something like, based on our entire discussion so far, generate a concise, updated set of operating instructions and key goals for this project. Include the target audience, the required tone, and the main constraints we've established.
So you're asking it to synthesize the rules and goals that have emerged, not just the factual content. You're creating a new condensed system prompt from the dialogue.
Precisely. You're creating a low-entropy summary of the operational logic. This distilled context is much shorter, so it's cheaper and faster to process. But critically, it preserves the core rules and intent.
And then the AI refers back to that distilled summary instead of wading through the whole messy history.
That's the idea. It's an explicit act of user-driven entropy reduction within the short-term memory. You're periodically cleaning house, ensuring the AI stays focused on the refined goals and rules, combating that fading effect.
That's a powerful technique for managing the RAM. But what about knowledge that needs to last beyond this single chat session? We need long-term memory, the hard drive.
Yeah, and this is where things get really challenging, even for today's best models. Honestly, true autonomous long-term memory across sessions is still largely unsolved commercially. Models tend to forget everything once you close the window.
So the burden falls on the user again. We have to manage the long-term context ourselves.
Pretty much, yes. There are 2 main ways: reinforcement and external storage.
Okay, what's reinforcement look like?
It means actively reminding the AI of your core long-term preferences or rules. Think of it like spaced repetition. If you always want your emails drafted in a certain formal tone or always need code comments in a specific format, you can't just tell the AI once and expect it to remember forever.
Because of that recency bias in short-term memory.
Exactly. So you need to periodically restate those core preferences, almost like giving a fresh instruction, to keep them top of mind for the AI within its operating context.
Okay, so periodic refreshers. What about stuff that absolutely must be permanent and non-negotiable?
That's where external storage comes in. This means taking your absolutely critical low-entropy instructions, the fundamental rules, the project constitution, if you will, and putting them into a separate, stable file.
Like a text file. Or something more structured?
Often something structured works best. Think Markdown files, MD, maybe JSON files, or even just a well-organized text document. This file contains the distilled essence of your long-term requirements, your operational habits, the non-negotiables.
And then what? You upload it every time?
Basically, yes. When you start a new session for that project, the very first thing you do is give the AI that external file. You instruct it. Read this document. These are the core principles and requirements for everything we do in this session. Adhere to them strictly.
So you're instantly injecting that low-entropy long-term context right at the start, overriding any potential drift.
Exactly. And this isn't just theoretical. We see this being incredibly effective in practice, especially in complex fields like programming or detailed analysis, methodologies like Trace Solo that rely heavily on these structured Markdown requirements documents.
Yeah, I've seen those mentioned.
That requirements doc is the external long-term memory. It acts as a constant reference point, allowing the user, or the AI itself, to constantly check its work against the established rules, ensuring course correction jupian, as the paper terms it.
It makes total sense now why that works so well. That external MD file is the ultimate low-entropy input, structured, precise, unambiguous. It anchors the entire session.
It's the user taking direct control of the long-term entropy, ensuring the machine always starts with and can always refer back to the cleanest possible statement of intent.
Okay, so we've covered acquisition and memory, how the context gets in, and how it's stored short and long term. Now, principle 2. How does the AI actually use this context once it has it? How does it select the right pieces? There must be some internal processing first, right? It can't just work with raw data feeds.
No, definitely not. Before selection even happens, the AI needs to process all that incoming raw data, the text, the video, the sensor readings, all that high-entropy chaos. The sources call this internal process the self-baking system, Zhiaoshiton.
Self-baking, like it's cooking the raw ingredients into something usable.
That's a good way to think about it.
Yeah.
It's the AI's internal kitchen. It takes the raw, potentially multimodal data streams and converts them into structured, organized knowledge.
How does it structure it? What's the output of this baking process?
It typically generates some form of internal knowledge graph or maybe a structured representation like a mind map. It uses techniques like entity extraction, relationship identification, think embedding vectors, but also organizing the information into logical connections.
So instead of just having a raw transcript saying, John argued with Mary about the budget on Tuesday, the self-baking system might store structured triples like entity, John action, argued with entity, Mary and topic, budget time, Tuesday.
Exactly. It moves from messy, high-entropy sequential data to low-entropy structured knowledge objects. This makes retrieval later on much faster and more accurate. It's actively cleaning and organizing the context before it even gets queried.
Okay, the context is acquired, stored, and now internally structured, baked. The next big challenge is selection. I ask a new question. How does the AI figure out which of these potentially millions of structured context pieces are actually relevant to this specific question right now?
This is a huge area of research and development. The default method used in most systems today is still primarily based on semantic relevance.
Meaning, like keyword matching.
More sophisticated than basic keywords usually. It involves vector embeddings. The AI calculates the mathematical meaning of your query and retrieves context blocks, whose vector representation is closest, most similar in that high-dimensional space.
Okay, find stuff that talks about similar things.
Right. If you ask about tax strategy, it pulls up context blocks that are semantically close to tax strategy.
But we already know that's not enough, right? Something can use the same words but be totally irrelevant to what I need now, like that old tax strategy conversation from 3 years ago. Semantically similar, operationally useless.
Precisely. That gap between just finding similar words and finding actually useful information is the major limitation of current era 2.0 retrieval, which is why the SJTU paper argues for a much more sophisticated approach, multidimensional selection.
Okay, multidimensional. What dimensions are we talking about? This sounds like the path towards smarter context use.
It is. The paper suggests that future, more capable AI needs to move beyond simple semantic similarity and evaluate context based on at least 5 key factors, ideally simultaneously.
All right, let's break down these 5 factors. This feels like the blueprint for truly contextual AI. Factor 1 is the baseline we already have, semantic relevance.
Yep, got to start there. Vector matching, similarity scores. Necessary, but definitely not sufficient.
Okay. Factor 2.
Factor 2 is logical dependence. This is crucial. The AI needs to check. Does this piece of context actually align logically with what I'm trying to do right now? with my current goal.
How would it check that? Can you give an example?
Sure. Let's say you're actively planning a business trip to London. You ask the AI, remind me about the meeting agenda. Semantically, it finds a context block mentioning a meeting agenda involving a Project Alpha. Okay, semantic match. But logical dependence asks, is Project Alpha related to the current London trip? Or was that agenda from a completely different project context 6 months ago? Only if it logically connects to the current task should it be prioritized.
So it needs some reasoning ability, not just pattern matching. Okay, that makes sense. Factor 3 tackles the memory issue we discussed. Timeliness or shihoxing.
Exactly. This factor gives higher priority to more recent context. In a dynamic, ongoing task, information from yesterday is usually more relevant than information from last month, even if the topics are similar.
And this directly supports that distillation technique we talked about.
Absolutely. A distilled summary of conclusions created yesterday should logically be weighted much higher than the raw conversational data it was derived from weeks ago. Timeliness keeps the focus on the current state of the operation.
Okay. Factor 4 seems based on experience, usage frequency.
Yeah, this is about learning what works. If a specific piece of context, maybe that external requirements document we discussed, has been pulled in and successfully used to generate correct answers for 90% of your relevant queries in the past, the system learns that this context is highly reliable and valuable for you.
So it prioritizes context that has proven useful repeatedly. It learns your go-to resources.
Exactly. It's the system reinforcing successful patterns. This knowledge source reliably helps achieve the user's goals.
And the 5th factor brings the user back into the loop, user feedback.
This is vital for fine-tuning. When the AI retrieves context X and uses it to answer your query, you need mechanisms to give feedback. If the answer was wrong because it used irrelevant context, you should be able to signal that, no, ignore that source, or that information is outdated.
And conversely, if it used context perfectly.
You signal that too. Yes, that's exactly the right information. This explicit positive and negative feedback directly trains the selection model over time, teaching it which connections and sources are genuinely helpful for your specific needs and workflow.
Wow. Okay, if an AI can genuinely integrate all 5, semantic relevance, logical dependence, timeliness, usage frequency, and user feedback, then we move beyond just passive retrieval.
That's the transition to active context referencing, the hallmark of Era 3.0. The AI isn't just reacting to keywords. It's actively inferring what context is needed based on the situation, the history, the logic, the feedback. It's reasoning about the context itself.
That complex, multidimensional selection process is how the machine internally bridges that high to low entropy gap for retrieval.
Precisely.
Yeah.
It's the internal mechanism catching up to the external complexity.
Okay, we have covered a ton of ground here. The fundamental entropy gap, the 4 eras of context engineering, the deep dive into AI memory RAM, hard drive, distillation, external storage, and now this multidimensional context selection. Let's bring it full circle. Back to the question that started this. Prompt engineering versus context engineering. Where do they stand now?
Having gone through all that, I think we can say with much more clarity, prompt engineering is absolutely the initial foundational subset of context engineering. It's the very first step. It's the initialization principle.
It sets the stage, and the quality of that initial prompt really matters in this whole entropy reduction war, doesn't it?
Immensely. A really well-crafted initial prompt is itself a powerful act of entropy reduction.
How so?
If you start with a prompt that's already low entropy, maybe it clearly defines the AI's role, specifies the desired output format, lists key constraints up front, you've massively simplified the AI's starting task.
Yeah.
You've essentially handed the infant machine that perfectly pureed steak right from the get-go.
You're minimizing the initial ambiguity.
Exactly.
Yeah.
And if that foundation, the prompt, is solid and clear, then the context that builds on top of it, the subsequent dialogue, the distillation efforts, the selection process, is much less likely to go off track. The AI spends fewer resources correcting bad assumptions and more resources actually generating high-quality output.
Whereas if you start with a really vague, high-entropy prompt,
the AI has to fight an uphill battle from the start. It might take dozens of conversational turns just to nail down your actual intent. That initial ambiguity can compound, making distillation harder, increasing the chances of the fading effect messing things up later. A great prompt is like giving yourself a huge head start in the entropy reduction war.
So the takeaway isn't prompt engineering is dead. It's that good prompting is more important than ever, especially as the first step in building a good context.
Absolutely. It's crucial for laying a clean foundation in our current Era 2.0 systems. And looking ahead, it'll likely remain a key tool for initializing the AI's understanding in the more advanced 3.0 and 4.0 stages, telling it which scene to pay attention to, what long-term goals are paramount. They're totally complementary. One is the whole system, the other is quality control for the initial input.
Context engineering is the whole factory. The supply chain, the machinery, the quality checks. Prompt engineering is ensuring the raw materials you put in at the start are top-notch.
That's a great way to put it. Context engineering covers the memory systems, the self-baking, the 5 selection factors. Prompt engineering makes sure that first interaction, that first piece of input, is as clean and low entropy as possible, setting the whole process up for success.
Okay, let's try to wrap this up for everyone listening. We started with that core problem, the entropy gap, that disconnect between how we naturally communicate and how machines need information.
Right. For the humans, precise machines.
We then identified context engineering as the overall strategy, the system for bridging that gap, for fighting the entropy reduction war. We traced its evolution through 4 eras, from simple translation to potentially predicting our needs.
And crucially, we got into the practical weeds. We talked about managing the AI's memory using active context distillation for short-term focus and relying on external storage like those structured MD files for long-term consistency. Those are things you can actually do.
Right, and understanding how the AI should be selecting context using not just semantics, but logic, timeliness, frequency, and feedback helps you understand why it sometimes fails now and how to potentially guide it better.
The big takeaway for you, the listener, is that moving beyond basic prompting means starting to think about the system. How does the AI process information? How does it remember? How does it choose what's relevant? Mastering that system is how you go from feeling frustrated to actually getting the AI to understand and execute complex intentions reliably.
You learn not just what to say, but how the machine hears you.
Exactly. And thinking about that future, particularly Era 3.0 and 4.0, where the AI relies on that passive multimodal data collection, our location, health signals, visual input.
Yeah.
And it raises a really interesting, maybe slightly unsettling question that goes beyond the technicals we discussed. If the AI gets so good at gathering context that it builds this incredibly detailed world model of us, understanding our patterns, our habits, maybe even better than we understand them ourselves.
Where are you going with this?
Well, what happens when the context the AI gathers starts to reveal things about us that we aren't consciously aware of? Deeply ingrained biases we hold, patterns of self-defeating behavior, things we might even unconsciously try to hide.
So if the AI understands our context perfectly, including the parts we don't acknowledge, could our own internal high-entropy self-deception become the next barrier, the next thing context engineering needs to figure out how to handle?
It's a provocative thought, isn't it? Maybe mastering the machine's context is just step 1. Step 2 might be using that mastery to help us understand and maybe engineer our own.
Definitely something to mull over next time you're staring at that blinking cursor, figuring out what to type. Thank you for joining us on this deep dive into the entropy war and the world of context engineering. We'll see you next time.